Okay, let's do a little verbal test. You guys were shown something like this. That's called exponential form. Can you convert that to logarithmic form? Yes.
Y equals log A.
Yeah, this is true if and only if, or I don't remember. In the video, I might have used the double-sided arrow. They both mean equivalent to. So a to the y equals x is equivalent to y equals log base a of x. That's essentially our working definition of logarithm or logarithmic form. This is log form, logarithmic form. This is exponential form. So this is the big property. This is the product rule. And I'm going to answer the question why, because I don't want it to keep you up tonight, right? I don't want you losing sleep thinking, oh gosh, why is the product rule true? That just looks weird. What, you don't think that would happen? You don't think you'd lose sleep over that? Let's start with the m times n, just the input on the left side. So m times n, okay, another name for m, a weird way to write m, you could do it like this. You could write it as a to the log base a of m. And another name for n, so this is times, another name for n is a to the log base a of n. Okay, wait, where am I getting that from? Why is m equal to a log base a of m? So this is m. Because you're just composing inverse functions. A to the log base a of m, they undo each other. It's just m. A to the log base a of n, you're composing inverse functions. It's just n. The a and the log base a, because a is the exponential function, they undo each other. So you say, well, why would you write it in a more complicated way? Well, what are you doing on the right side? What are you multiplying? Do the bases look alike? You're multiplying like bases on the right side. So, can't we keep the base and add the exponents? Log base a of m plus log base a of n. So a to that entire sum. Isn't that true? That's one of the laws of exponents, right? So we're saying the left-hand side hasn't changed. We're saying m times n equals a to the log base a of m plus log base a of n. We're done, except just you got to switch it to logarithmic form. And we've got the product rule. What happens if you switch it to logarithmic form? What goes by itself on one side if you switch it to logarithmic form? So the exponent, which is that entire sum, I'm going to put it on the right-hand side. Log base a of m plus log base a of n. So that sum is the exponent on base a that produces m times n. This guy is the exponent. Oh, we call the exponent a logarithm, right? Let me make a little bit more room here. It's the logarithm base a that produces m times n. That's all I'm doing is switching to logarithmic form. This guy, the exponent, goes by itself on one side, right? It is the exponent, log is another name for exponent, on base a that produces m times n. All I did was switch this statement from exponential form to logarithmic form, and I've got the result. I've got the product rule.